guys, it's time to do the conclusion on block AFD, which is the introduction to the mechanical energy equations. Hopefully you got the idea of what we are planning to do, what do we need to do, friction loss, pressure head, velocity differences, diameter, flow rates, and so on, the pump requirements. And the interesting part right here is this is just a brief introduction, guys, because if you recall, we didn't calculate friction, it was always given to us. We got very simple problems, let's say only singular or single in series problem. But what will happen if you have, I don't know, maybe two pipes, parallel flow? How will you do it? Well, this, once again, it's a brief intro. You need to get the idea, and then we start analyzing these cases, which are, of course, in the next sections. We will learn a little bit more on pumping, how to choose the best pump, how do we get more revolutions, how do we get more head, system curves, and so on. Friction loss, we're going to calculate friction loss on valves, fittings, and wall. We're going to measure fluids because it's very easy to tell you this pipe has, I don't know, this volumetric flow rate. But how do you get that volumetric flow rate? You need to use measuring systems. You need to learn a little bit more on piping, pipe roughness, type of materials, and sizes, international size, and so on. And parallel versus series system. Okay? If you really like this, I will definitely recommend you check out all the blocks and the master. Oh, I love block number 6 because it is the place in which I will get pump, how to choose a good pump for a system, how to calculate the friction loss, how to choose the pipings, how to measure this volumetric flow rate, and parallel or series system. You will have everything here. Yeah, that's essentially what I wanted to tell you. Let's go to what you should know by now, guys. If you maybe think you're not that comfortable or you want to review, I will definitely recommend you, because if you keep going with little holes on your knowledge, you will have problems as you go on. So, first things first, you should know by now what type of problems we're doing. Of course, we're not doing these very technical problems in which you calculate the friction loss in this little segment of the pipe. No. We're going to essentially calculate how much pumping energy we need to move fluid A to fluid B. Recall that this is incompressible flow. This is part number 1, guys. So we are talking about liquids at constant density. Therefore, we can apply the mechanical energy equation. We know about kinetic energy, how to relate velocities, volumetric flow rates, and diameters of pipes. We know about the potential energy, that it's very important to do a reference and choose the y-axis correctly or easier to understand. We know about pressure, what's pressure head and what does that mean. We know how to calculate pumps, energy, and efficiency, how much energy do you need to do and how much energy is required, and so on. Workout, you know about the turbine. We didn't actually do an exercise with the turbine, but it's actually very easy. And friction loss, we know a little bit on that, only the basics. We're going to go and see a little bit more of that on AFD, which is Applied Fluid Dynamics number 3, the famous friction loss. And you can solve some basic problems in fluid dynamics, which are in incompressible flow. So if you get a gas, you're probably not going to be able to do it. If it's a liquid, you are probably going to be able to do it. You want more questions and problems to practice, guys? It's very important to do it. I got some solve and explain problems, video explain. I do it for you guys. You need to learn, and I would definitely recommend you try to do it by yourself first, get some doubts, and then open the video, check out if it's what you think about, why I did some process, why did I cancel some units or some, let's say, pressure head or velocity and so on. Don't let this for later. If you continue with the theory, guys, without doing problems, you will definitely regret it, because you will get so overwhelmed with the theory and you will not be able to do the problems, so no, don't do it, guys. So just a reminder, go to Chemical Engineering Guide, check out the courses, go to the Momentum Transfer Operations section, and then go to Apply Fluid Dynamics. I remember you guys that this is part number 1 in compressible flow. So click on that and then search for the mechanical energy equation. Contact information. So if you're enrolled in the course, please let me know if you have any doubt. Send it to my contact email, contact@chemicalengineeringguide.com. Say hi on Twitter. Like my Facebook page. I got many stuff right there. And yeah, essentially it's everything, guys. That's the reference we were using. We got a little bit on the unit operations and the applied fluid mechanics. This will be on the next blog, so keep doing good work, do problems, and see you in the next blog, which is AFD2. It's about piping, fittings, instrumentation, and so on. This was a free preview. You want to get full access, go to my incompressible flow course. The link is in the description of the video. You will get all access. Not only that, you get a very straightforward, user-friendly interface. So for instance, if you were analyzing or studying pumps, you have it here, the pump block, and then you have the sections. If you were, for example, studying the types of pumps, you can go here, and you have all the classes right here. Not to mention that you also have introduction and conclusion of every one of these. So for instance, if you were studying positive displacement pumps, the video is right here. You were studying positive displacement pumps in rotatory and reciprocal are also included here. Centrifugal pumps, which is a very important topic in this course, you have it right here.